In these last problems, first one here, average value. Remember, we're thinking of average value. We want to think of area equaling a length times a width. We know the width because we're giving an interval. We know an area, that's found by taking an integral. So what we're finding, the length, is really like your height, your average height of an entire function. We want to take the average of that. So really we're looking to find the length. Area is integral, the length is our average height, and our width is what we know. So to find our average value, we're really going to take the integral and divide by the width. So let's first take the integral here. It's the integral of 3x squared plus 8x minus 1. And we're going to integrate it from -1 to 4. So when I integrate, I'm going to get x cubed plus 4x squared minus x evaluated at 4 and -1. If I plug in 4, I should get 64 plus 64 minus 4. So that's 128 minus 4, 124. Plug in -1, I'll get -1 plus 4 and minus -1, so plus 1. So that'll add up to give me 4. Subtract those two numbers, and I get 120 as my integral. So that means the average value is equal to 120 divided by the width of my interval is 5, from -1 to 4, and that gives you your answer of 24. In the next set, you're using this piece of information to find these different variables, or these different integral values. So this one, it's from 5 to 3 instead of 3 to 5. When those are just flipped around, all you do is you take what the integral would be and negate it, make it negative. For this one, 3 to 10, well, that's the same as saying the integral of 3 to 5 plus the integral from 5 to 10, which are the two things that we know. So the integral from 3 to 5 is 8, from 5 to 10 is 5, so you add them up to get 13. And for this one, the only difference between this guy and the one we were given is that it's 4 times f of x. That just means it's 4 times whatever that value was, which was 8. So 4 times 8 to give you 32. Now the last two, it's the second fundamental theorem of calculus. All you have to do is plug x in for each of them. So it's now x cubed minus 5 sine of x. And then multiply by derivative of the inside, like a chain rule. The derivative of the top. Well, the derivative of the top is just 1, so you're done. In number 18, when you plug this in, it'll be tangent of x cubed, and 2 times, well, it'll be x cubed to the 4th power. So that's, just to rewrite it, tangent of x cubed plus 2x to the 12th. Now again though, we have to multiply everything by derivative of the inside, which would be times 3x squared. That's just the chain rule that comes into play when you take this derivative. So keep an eye on what's up top.